In a relationship between two variables, if one variable is a constant multiple of the other, then they are said to be directly proportional. A linear model with formula y equals mx relates two variables x and y that are in direct proportion. The graph has a y-intercept of 0. Okay, that's clear from this because b is 0, y equals mx plus b. b is the y-intercept. The y-intercept is 0, so that's why that's 0. The gradient is the constant of proportionality, m equals y on x, for any point xy on the graph. So that's the gradient. We know that. It's the change in y over the change in x. This type of linear model is used in conversion graphs. Example 8. This is a conversion graph from pounds to kilograms. So it's kilograms here and pounds. So when it says from pounds to kilograms, pounds is the independent variable and kilograms is the dependent variable. We're going to choose pounds, for example, 10 pounds. Go up here, we can find how many kilograms that is. A, use the graph to convert 20 pounds into kilograms. And that's the answer, 9. And it says reading off from the graph, when x is 20, kilograms is 9 there. Okay, so we go to 20, up to there and across there is 9, 20, and that's 9. So that's pretty straightforward. B, find the number of kilograms equivalent to 1 pound. 1 pound equals 0.45 kilo. You could just go from here 1 and you go across and it looks about half, doesn't it? Half of 1 kilogram. Reading off from the graph, the answer would be a little less than a half. Looking for greater precision, it is clear that as the graph is a line that passes through the origin, the variables are directly proportional. Let P be the value we are looking for. Both 29, we've got that point there, 20 and 9, and 1 and P, right, because we want to know 1 pound how many kilograms, so we've given this P, this letter P here. For some reason they chose P. It's funny, they probably should have chosen a K. Lie on the graph. So 9 on 20 equals P on 1. So these are just ratios. We're saying that 9 kilograms is 20 pounds. So how many kilograms is 1 pound? We can set that up, do a bit of cross multiplying with that 1 anyway, and we got P equals 9 on 20. And 9 on 20 is 0.45. Hence, write down the gradient of this line. Well, m is 0.45. We just found that. We said it's the rise over the run. So the rise here is 9, and the run is 20, and 9 over 20 is 0.45. And remember, we could have taken any rise over the run. We could have taken a run of 10 and a rise of 4.5. That's also 0.45. D, find a model for k, this function k, where k is the number of kilograms and x is the number of pounds. Well, that's the answer there. It makes sense because we're using y equals mx plus b. B is 0 because the y-intercept is 0. And we use m, and we just, in C, we saw that m was 0.45. So that would be the model. This function k equals 0.45x. The equation is the form k equals mx, and m is 0.45. E, use your model to convert 17 pounds into kilograms. Remember, x is the number of pounds, so we can just put the 17 in there, and you got 0.45 times 17, and the answer is 7.65 kilograms. And that's how you'd write it as a function. K, 17, we said that is pounds. Right, the whole left-hand side is the function, that's kilograms. But the x is pounds. So we write it like this, you've seen that before. K, 17 equals 0.45 times 17. Where you've got an x, you replace them with 17. And then you've got 7.65 kilograms. 2, 25 kilograms into pounds. So now we've got to do 25 kilograms into pounds. Kilograms is the left-hand side. It's the whole function. So 25 equals 0.45x. And there we divide both sides by 0.45, and we get x equals 25 divided by 0.45, which equals 55.6. That's why it's 55.6 pounds. Let's give some hints for the solutions to exercise 5E. 1, the graph shows the equivalence between pound sterling and US dollars. So pound sterling is on the x-axis, US dollars is here. It goes through 0, so we can model this function because x and y are in direct proportion. Now that's got a U there, but I think that's a Y there. Okay, so that's the x-axis, y-axis there. A, write down the coordinates of a point on the graph that gives you some accurate information about the relationship. Now it's a bit hard to see here, but you'd choose a point where it crosses the grid lines. Where the grid lines intersect, you should use something like that. They chose 9, and if you go across there, that's 12. I mean, you could make an argument that 20 was 27 here. Okay, we'll just use their one. They chose 9 and they've got 12. B, using your point from part A, find the gradient of the line. Well, if we're going to choose the point 9 and 12, that point there, then the rise over the run, because it's 0, right? It passes through 0. So we can just say it's 12, that's the rise, divided by 9. And that will give us the gradient. C, find the formula for the model UX. Oh, it actually was a U. Where UX is the number of US dollars and X is the number of UK pounds. There, they chose U for US and they've also got a U for UK there. But we've got to associate that with the US dollars. Okay, we can do that function now because we know the gradient. We said the gradient was 12 over 9. So we can model that as U, the function U, equals 12 over 9 times X. And 12 over 9 becomes 4 over 3. So the model is the function equals 4 over 3x. Now once we have the model, we can just substitute these numbers in there. Use your model to find the exchange rate. So the exchange rate from UK pound to US dollar, so 1 pound equals how many dollars? Okay, you put that in the formula. Number 2, the amount in UK pounds equivalent to $100. The US dollar is our is the function value. So the function 100 equals our 4 over 3x, and you have to solve for x, and that'll give you the pound sterling. 2, it is given that 5 miles equals 8 kilometres. The figure shows a conversion graph of miles into kilometres. Kilometres is the function, right, the vertical axis, and miles is a horizontal axis. A, find the value of A. Well, we can do that because we know that 5 miles is 8 kilometres. So on here, if 5 is 8, then 1 must be 8 divided by 5. So that A would be 8 divided by 5, which is 1.6 kilometres. B, write an equation to express the number of kilometres in terms of the number of miles. Well, the number of miles is our independent variable on the x-axis. So all we need to do is to find the gradient, and we can make our model. Now the question has asked us to use K and M, so we're using K, then a bracket, then M, and then a bracket, equals, and the right-hand side we need to know the gradient. Now we know the gradient because that point there is 8 on 5, or 1.6. That's the rise, right, the Y value. So we've got 8 on 5 divided by 1. So that means the gradient's 8 on 5. And therefore, we've got, on the left-hand side, we've got K bracket, M bracket, equals 8 on 5 times M.